isotopes, and we are also going to look at how we can calculate relative atomic mass according to our syllabus here. So without wasting much of our time, let us define isotopes. What are isotopes? Okay, so isotopes are atoms of the same element having the same number of protons but a different number of neutrons or different number of mass or mass number. An isotope is an atom of the same element having the same number of protons but different number of neutrons and mass number. Okay, so we have an example here. We have two isotopes. We have the first isotope and we have the second isotope. So we can see that these two isotopes have the same proton number but different mass numbers. As we can see, here we have 4, here we have 5. So we are going to look at we are also going to look at uses of isotopes. So where can we use isotopes? So the number one use of isotope, radioisotopes. For example, radiocobalt are used in the treatment of cancer. Radioisotopes, e.g., radiocobalt are used in the treatment of cancer. Isotopes like uranium-235 are used in the manufacturing of nuclear weapons or nuclear bomb. Hydrogen isotopes are also used in the study of nuclear energy. Hydrogen isotopes are also used in the study of nuclear energy. Carbon-14 isotopes or carbon-14 isotope is used in a radiocarbon dating machine to determine the age of fossils. So carbon-14 is mostly used by archaeologists who studies the ancient remains. So these are uses of isotopes. So we have seen that isotopes are very useful according to what we have presented here. By the way, you are free to pause the video and assimilate the information given on the screen. So mass spectrometer. Mass spectrometer is the one that is used for separation of isotopes of an element and the determination of relative atomic mass. So we use mass spectrometer. We use mass spectrometer for separation or to separate isotopes from an element, and we also use the same mass spectrometer for determination of relative atomic mass. Okay, so what is relative atomic mass? What comes into our mind whenever we hear the term relative atomic mass? So the relative atomic mass of an element is the mass of one atom of an element compared to their respective masses, or compared to carbon 12, compared to carbon 12. So this is the relative molecular mass. So the relative molecular mass of an element is the mass of one atom. The mass of one atom. Let us also look at the examples of isotopes. So the first example that we are going to look at carbon. So carbon has 3 isotopes. Carbon has 3 isotopes. Carbon 12, carbon 13, and the carbon 14. Carbon 12, carbon 13, and carbon 14. So these are 3 isotopes of carbon. So carbon has 3 isotopes. So as we can see, these isotopes have same proton number or same atomic number, but different mass numbers. As we can see, here we have 12, here we have 13, here we have 14. How can we find how can we know the number of neutrons? Because when defining isotope, we said an isotope is an atom of an element with the same number of protons but different neutrons. So how can we determine, or how can we calculate the number of neutrons? So this is how we can calculate the number of neutrons. So we are going to say the mass number minus the atomic number. So in this case, as we can see, the atomic number is 6. So 12 minus 6, we are going to get 6. So the neutron number, or the number of neutrons, is 6. Let us also find the number of neutrons for carbon 13. So we are also going to apply the same concept by saying the number of neutrons is equal to 13 minus 6, which is the atomic number, is equal to 7. So 13 minus 6 is equal to 7. Let us also determine the number of protons of carbon 14. So carbon 14, we are also going to say the number of neutrons is equal to 14 minus 6. 14 minus 6 is equal to 8. 14 minus 6 is equal to 8. So these are some of the examples of isotopes. We are also going to look at hydrogen. So hydrogen also has 3 isotopes. We have hydrogen 1. So hydrogen 1 is also called original hydrogen. So we have hydrogen 1. We have hydrogen 2. Hydrogen 2 is also called deuterium. It's also called deuterium. We also have hydrogen 3. Hydrogen 3 is also called tritium. So we have hydrogen 1, we have hydrogen 2, and we have hydrogen 3. How can we determine the neutrons of these 3 isotopes? So let us start with the hydrogen 1. So hydrogen 1, we have the mass number, which is 1, and the atomic number, which is 1. So number of neutrons is equal to 1 minus 1. 1 minus 1 is equal to 0. So the number of neutrons here is equal to 0. Let us also determine the number of neutrons here. So this is hydrogen 2. So we have the mass number, which is 2. So we are going to say 2 minus 1. So 2 minus 1 is equal to 1. So here the number of neutrons is equal to 1. The number of neutrons is equal to 1. we also have this one, which is hydrogen 3. Hydrogen 3, we are going to say the number of neutrons is equal to 3 minus 1. 3 minus 1, we are going to get 2. We are going to get 2. So these are some of the examples of isotopes. These are some of the examples of isotopes. Now let us look at how we can calculate the relative atomic mass. So to find the relative atomic mass, we are going to say the relative atomic mass is equal to relative atomic mass of isotope A times percentage abundance of A divided by or over 100% plus atomic mass of isotope B times the percentage abundance of isotope B over 100%. So this is the formula. This is the formula that we'll be using throughout this video. So therefore, I solicit for your attention so that we can move together. Okay, so that we can move together. We have an example here. We have an example here. An element has two isotopes. An element has two isotopes. Isotope A with a mass of 20, the percentage abundance 80%, and the isotope B with the mass of 22, percentage abundance 20%. Calculate the relative atomic mass of the element. Calculate the atomic relative mass of the element. So to calculate the relative atomic mass of the element, the first thing that we are going to do, we are going to write the formula. We are going to come up with the formula. So relative atomic mass is equal to mass of an isotope A times percentage abundance over 100% plus mass of an isotope B times percentage abundance divided by 100%. Divide by 100%. So this is the formula that we are going to use to find the relative atomic mass of the element. So the first thing that we are going to do here is to identify the we are going to identify the atomic mass of isotope A. So the atomic mass of isotope A is 20. The atomic mass of isotope A is 20, as we can see here. Then let us also identify the atomic mass of B. So the atomic mass of B is 22. The atomic mass of B is 22. The next thing that we are going to do here is to identify the percentage abundance of A. So the percentage abundance of A is 80%. So 80% is the percentage abundance of A. Let us also identify the percentage abundance of B. By the way, I've already identified these information. I'm just pointing so that you see where we'll be getting these numbers. I've already identified these numbers. So the percentage abundance is the percentage abundance of isotope B is 20%. Is 20%, as we can see here, is 20%. Now let us plug in these values in our formula. Okay, so we are going to say the relative atomic mass, or let us come up with data so that you see where these numbers are coming from. So the data collection. So isotope A, the mass of isotope A, the atomic mass of isotope A is 20. The atomic mass of isotope B is 22. The percentage abundance of isotope A is 80%. The percentage abundance of B is 20% according to our question. So this is the box where I'll be picking questions from. So we'll be picking questions from this box. Now let us plug in these values that we have collected from the question. So the atomic the atomic mass is equal to 20 times, so where there is isotope A, we have written 20. Where there is a percentage abundance, we have written 80% over 100. Where there is isotope B, we have written 22. Where there is percentage abundance of B, we have written 20% divided by 100. So we are going to say the relative atomic mass is equal to 20 times 80. We are going to get 1600 over 100 plus 22 times 20. We are going to get 440 over 100 percent. Let us work out. So we are going to say formula atomic mass is equal to 1600 plus 440 percent divided by 100. So you are free to use your calculator. So if we say 1600 divide by 1600 divide by 440, we are going to get 2040 divided by 100. We are going to get 2040% divided by 100%. So therefore, the relative molecular mass is equal to 2040 divided by 100 is equal to 20.4. So this is our answer. So as we can see, we have successfully managed to find the relative atomic mass of the element. So we have answered this question. Now let us shift to the next example. We are also going to answer this one. This one should be example 2. I made the mistake here. This one is supposed to be example 2, so to say. Chlorine has two isotopes, chlorine 35 and chlorine 37, with abundance of 75% and 25% respectively. Calculate the relative atomic mass for chlorine. Calculate the relative atomic mass for chlorine. Okay. So even here, we are going to do the same. The first thing that we are going to do is to write down the formula. So relative atomic mass is equal to atomic mass of isotope A times the percentage abundance of isotope A divided by 100% plus the atomic mass of isotope B times the percentage abundance of isotope B over 100%. So as we can see, we are still using the same formula. Okay. Now let us identify the values. So the atomic relative mass of isotope B is isotope A, so to say, is 35. Okay, 35. Let me point 35 here. So we have seen that the atomic mass of isotope A is 35. Let us also identify the percentage abundance of A. So the percentage abundance of A is 75%. The percentage abundance of A is 75%. Then the atomic mass of isotope B, is, let me point so that we can see. So the atomic mass of B is 37. The atomic mass of isotope B, the atomic mass of isotope B is 37. Let us also identify the percentage abundance of B. So the percentage abundance of B is 25%. The percentage abundance of B is 25%. Okay. The next thing that we are going to do, we are going to make use of this formula, or we are going to plug in the pointed values into our formula. So we are going to say relative atomic mass is equal to 35 times 75 over 100, 37 times 25 over 100. So we all know where these values are coming from. We have seen where these values are coming from. So if we say 35 times 75, we are going to get 2,625. And 37 times 25, we are going to get 925 over 100. Let us work out. So the relative atomic mass is equal to 2,625 plus 925 divided by 100%. Divide by 100%. So the relative atomic mass is equal to 3,550 divided by 100. So if we say 3,550 divided by 100, we are going to get 35.5. So this is our relative atomic mass of chlorine. Okay, this is our relative atomic mass of chlorine. So as we can see, we have successfully managed to find the relative atomic mass of this element, which is chlorine. Let us move to the next example. We move to the next example, which is our example 3. Example 3, an element has 3 isotopes with the following data. Isotope X 5.0. Then the percentage abundance is 20%. Isotope Y 7.0. Percentage abundance 50%. Isotope Z 8.0. Percentage abundance 30%. Calculate the relative atomic mass. Calculate the relative atomic mass. So even here, the first thing that we are going to do is to write down the formula. So we are going to say the relative atomic mass is equal to atomic mass of X times the percentage abundance divided by 100%, atomic mass of Y times the percentage abundance divided by 100% plus atomic mass of Z times percentage abundance divided by 100%. So we need to remember that here we have three isotopes. So no wonder we have added this fraction here. No wonder we have added this fraction. We have 3 isotopes. Okay. So as usual, the next thing that we are going to do is to identify the numbers or to identify the values that we are going to plug in the formula. Okay. So the atomic mass of X, let us come up with data first. Data collection. So the atomic mass of X, the atomic mass of X is 5.0. So isotope X 5.0. The atomic mass of Y is 7.0. 7.0. Isotope Y 7.0. The atomic mass of Z is 8.0. 8.0. Okay, 8.0. Now let us also locate the percentage abundances. Okay, so the percentage abundance of X, the percentage abundance of X is 20, as given here is 20%. Then the percentage abundance of Y is 50. The percentage abundance of Y is 50. The percentage abundance of Z is 30%. The percentage abundance of Z is 30. So we have data. So where are we getting these values? So this is where we are getting these values. So the first one, we have the atomic mass of isotope X and the percentage abundance of isotope X. The second one, we have the atomic mass of isotope Y and the percentage abundance of isotope Y. The third one, we have the atomic mass of isotope Z and the percentage abundance of isotope Z. Now let us plug in these values in our formula. So we are going to say the atomic mass times 20% divided by 100, 7 times 50 divided by 100, 8 times 30 divided by 100. Okay, so we have all seen where these values are coming from. Now the next thing that we are going to do is to work out, we evaluate so that we can come up with our final answer. So we are going to say 5 times 20 is equal to 100, divide by 100%. 7 times 50 is equal to 350, divide by 100. 8 times 30 is equal to 240, divide by 100. Okay, so having the lowest common denominator, which is 100, we have 100 plus 350 plus 250 So if we add these numbers, we are going to get 690 divided by 100. So the relative atomic mass therefore is equal to 6.9. So 6.9 is our relative atomic mass of this element we are talking about. So this is our final answer. By the way, you are free to pause the video and understand the work given on the screen. So now let us extract some questions from past papers so that we can test our understanding. So the first question is coming from 2013 past paper, and the question is question 1. Chlorine has two isotopes, 35 and 37. Define the term isotopes. So remember, you are free to go back and start the definition of isotope. So we said isotopes are atoms of the same element having the same number of protons but different number of neutrons or mass number, or we can say and mass number. Okay, so as we can see, we have successfully managed to define isotopes, and the question is carrying 1 mark. Let us move to the next question, which is question B. Question B, state the number of neutrons in each of the following isotopes: chlorine 35 and chlorine 37. So we are going to start with chlorine 35. So to determine the number of neutrons, the first thing that we are going to do is to come up with data collection. So what have we been given according to our question? So we are given the mass, which is 35. We are given proton number, which is 17. The neutron number is what we are looking for. So therefore, we are going to say neutron plus proton is equal to mass. So neutron, the proton we have, which is 17 here, 17 according to our data collection here. We are going to group the like terms. The number of neutrons is equal to 35 minus 17. The number of neutrons is equal to 18. So 18 is the number of neutrons for chlorine 35, or is the number of neutrons of chlorine 35. Let us also find the number of neutrons of chlorine 37. So to find the number of neutrons of chlorine 37, we are going to do the same. The first thing that we are going to do is to come up with the data collection. Mass we have 37, proton 17, neutron is what we are looking for. So therefore we need to remember that neutron plus proton is equal to mass number. So the proton number is 17, the mass number is 37. We collect the like terms, 37 minus 17, we are going to get 20. So the number of neutrons of chlorine 37 is 20. So our answer here is 20. Our answer is 20. The next question The next question, draw the atomic structure of an atom of chlorine. Draw the atomic structure of an atom of chlorine. Okay, the atomic structure. Let me try to draw the atomic structure of chlorine. So the first two electrons are found in the first shell. The second 10 electrons are found in the second shell. Then the last 7 electrons are found in the last shell. And this last shell is called outermost shell. Outermost shell. Okay, so as we can see, we have 7 electrons in the outermost shell. The next question, give the formula of a chloride ion. So remember, this is a non-metal, and the non-metals have tendency of gaining electrons. So since this one is having 7 electrons in the outermost shell, for it to be stable, it needs to gain 1 more electron for this to be stable. So therefore, the formula will look like this: chlorine negative. So negative indicates gaining. Negative indicates gaining. The next question, which is question D, explain why the relative atomic mass of chlorine on the periodic table. Explain why the relative atomic mass of chlorine on the periodic table is not a whole number. So the reason why the relative atomic mass of chlorine on the periodic table is not a whole number is because it is the average of 2 isotopes, that is chlorine 35 and chlorine 37. So we are from calculating this one, so there is no need for me to elaborate more here. So we are from solving this one. So the reason why chlorine is 35.5 and not a whole number is because that 35.5 is an average of 2 isotopes, such as chlorine 35 and chlorine 37. Okay, we have answered this question. Let us also let me do this. Let us also extract one question from 2022 past paper, and this question is question A7. Question A7, the question reads, lithium occurs as a mixture of 2 stable isotopes, lithium 6, 7.5%, and lithium 7, 92.5%. The relative atomic mass of lithium is A. Okay, so to solve this one, we are also going to come up with the formula. We are going to say the relative atomic mass is equal to atomic mass of isotope A. In this case, isotope A is this one, times the percentage abundance of isotope A, which is the 7.5%, plus over 100% plus atomic mass of isotope B. The atomic mass of isotope B is 7, as we can see, times the percentage abundance, which is 92.5 over 100%. So the atomic mass, let us plug in the values. So the atomic mass here is 7 times is 6, so to say, as we can see, is 6 on top here. So 6 times 7.5 over 100% plus 7 times 7, which is here, times 92.5 over 100%. Let us work out. So the relative atomic mass is equal to 7 times 6 times 7.5 is equal to 45 over 100%. 7 times 92.5 is equal to 647.5% divided by 100%. We work out, we are going to have 45% plus 647.5 divided by 100. We are going to get 692.5 divided by 100%. So the relative atomic mass therefore is equal to 6.925. 6.925. So therefore our correct answer here is C. C is our correct answer, which is 6.925.